Hello. In this session, we are going to discuss about inter-process communication in operating system. So, what is meant by inter-process communication? When the processes are executing concurrently in the operating system, there are two possibilities. It may be an independent process or cooperating process. An independent process means it does not share data with any other process. It is a standalone process. There is no need for dependency on other process. It's called independent. But always that is not the case. There is a need for one process to share some data with other process. It's called cooperating. A process is to be cooperating process if it can affect or be affected by other processes executing in the system. That absolutely means that any process that shares data with other process is called cooperating process. Of course, always there is a need for one process to share data with other process. Then first, we have to understand what are the reasons for having process cooperation. First one is about information sharing. For example, I can copy a message from my mail. I can copy the content and I can post the message in my WhatsApp group. So what happened? I am having a content that is copying from one process and pasting in another process. So of course, the data is shared among two different processes. So it's for information sharing. The next one, computation speed up. Now, for example, I am having it's a multiprocess system. Assume multiprocess system. I am having quad core. So I have cores one, 2, 3, 4. Instead of doing a larger process, instead of doing a larger job by a single core, what I can do, I need to speed up the operation. I have to split the job and give it to the multiple cores at the same time. So whenever I am splitting the task, there is a need for splitting my data. So there is a dependency of data among the process. And next one, modularity. For simplifying my work, I need to make it as a functions to make it implement reusability functions. So then there is a need for sharing the data among process. So if a cooperating process requires an inter-process communication mechanism, that is IPC, that will allow them to exchange data. Exchange in the sense send data to and receive data from each other. These two processes are cooperating means it should have a proper mechanism to exchange data among them. So there are two fundamental models of inter-process communication. There are shared memory and message passing. Let's see. What is shared memory? You're having a region of memory that is shared by the cooperative process. You can think it of when you're having a college or school notice board. I can have a common notice board. Or if I want to inform something, I can post it here. I can write it here. If the next person is coming, they can see this and they know about the notice. If you want to write also, you can update, others can come and see. So it's the region of memory that is shared by the cooperating process and they will use that space to read and write data. It's called shared memory. And next one, message passing. So it's like messages. One process want to message, send to message, other process means it is used through sending messages. Through message exchanging is happening. So this is what happening between them. This is the architecture diagram. So when there is a shared memory, the process A and B, we have a kernel there. Of course, there is a single kernel, and we have a shared memory here. This memory is used by both A and B. One can read and one can write the both time. And in message passing, in addition to the kernel, I am having the message queue M0, M1, M0 like that. A message size grows on. One process may post a message and another process also post a message and read the posted message like that. It uses the message as an exchanging platform among two processes. And the message passing is useful for exchange small amount of data, whereas the shared memory is useful to handle larger size because it is available in a common space. It is easier to implement in a distributed system because of the messages. But in the shared memory, it is easy as it is accessing your memory is faster. So the usability depends on what kind of process and what kind of data is going to be exchange among two cooperating process. Now, as an IPC example, for the shared memory, we are going to discuss one standard example called producer-consumer problem. So there are two processes. Assume it's an abstract concept, two process. A producer is a process which produces information, and a consumer is a process that consumes the item or information that produced by the producer. So a producer produces information and consumer consumes the same. Can have an example. For example, I'm having a print program. So the print program, it will send the characters on by one. Meanwhile, the print driver will consume on by one. Similarly, I'm a compiler. The compiler produces the compiler code, which is consumed one by one by the assembler. So now, to allow the producer and consumer to work concurrently, so we should have a buffer of items to store by the producer, which is emptied by the consumer. So the buffer is nothing but it is a shared region of memory that is shared by producer and consumer. Always remember, a producer can produce only one item at a time, a consumer can consume one item at a time. This is the fact about producer consumer. And the producer and consumer must be synchronized so that the consumer does not try to consume an item if there is no production from the producer. Now let's see how it happens. So here we are going to discuss that there are two types of buffers we can use. One is unbounded buffer, other one is bounded buffer. From the name itself we can understand. Unbounded buffer means there is no practical limit on the size of buffer. So the producer can keep on producing items. The consumer can keep on consuming. Only thing is the consumer have to wait for new item because if the producer doesn't produce, the buffer is empty, the consumer has to wait. But there is no problem with the producer because they have an infinite space. The producer can keep on producing the new items. Second one, but the unbounded buffer is not always applicable because a single process cannot have allocated with a infinite space. So we should have a bounded buffer. In the bounded buffer, there is a fixed buffer size. So what happens if the buffer is empty? That there is no item to consume, the consumer has to wait. And if the buffer is full, there is no space to accommodate my new item, then the producer must wait. So wait, remember that if the buffer is empty, the consumer must wait. If the buffer is full, the producer must wait. Now let us see where we are going to implement this producer consumer problem in shared memory using a C program. Now I am having the buffer size is 10. I have the item. So the item may be of any structure. So I have maybe abstract item and I am defining the item of buffer size is 10. Now I have two integers in and out. So in and out. So what are the uses of in? In always points to the next free position in the buffer. Look at this next free position to add the new item produced by the producer. Whereas out always points to the first full position in the buffer. That is the pointer that is used by the consumer to consumer next item. Now let's see there are two situations. If in equal to out, what is the meaning of in and out? In and out are in is the producer pointer and out is the consumer pointer. If both are same equal means that means the buffer is empty. The buffer is empty. And the in plus 1 mod buffer size equal to out. Then what the meaning is? The out points to the maximum size of in. That means the buffer is full. By keeping it in memory, now let us see the two different codes of producer and consumer. Here I'm having the item is the next produced, while true. Infinitely it keeps on doing the job. That if while of in plus 1 modulo buffer size equal to out. That is if the buffer is full. If the buffer is full, the producer is blocked, do nothing. How long it is? Until there is an empty space. Once there is an empty space, it will produce a new item and store it in the buffer and update the counter size. This is happening in the producer. In the consumer, it will first check if in equal to out. That means if it is empty, there is nothing to consume, then do nothing. It's blocked. Otherwise, if there is an item to be consumed, in and out are not equals, then we'll retrieve the value in the out pointer buffer of out and consume it and update the out buffer. There the item is consumed and this is the consumer. And here this is how the producer and consumer are using one common buffer. This buffer is the shared memory among the in between the producer and consumer to work cooperatively. So this is the example of standard example of IPC, producer consumer problem.